Okay, curve sketching. Domain are your possible inputs. Meaning, if you have a square root, are there some values that won't work? Yeah. If you have a fraction, are things on the denominator going to have issues? Yeah. So the first thing you do is kind of look at your graph, look at what values mess it up. Where is it not continuous? That's your domain. Your range, think about how high or low is this graph going to go? Could that also, for your range, relate to your horizontal asymptotes? When your limit approaches infinity, doesn't that tell you if it's going to go up forever, down forever? Does it kind of give you a picture of the highest and lowest points at the end? This isn't as important to know your range, but it helps to kind of know how high or low is this graph going to go. Especially if you had a graphing calculator, you kind of can see it. How high or low? This is your inputs. This is your outputs. To find your x-intercepts, you set y equal to 0. Why are we doing x-intercepts? Well, it's the easiest point to find. Your x and y, the y-intercepts are when x is 0. These 2 points are the easiest 2 points to find. You could find other points, it's just these are the easiest. Because when you plug in 0 to y and 0 to x, it's way easy to solve, or tends to be. And when you're making a graph, it helps to have a couple for sure points. Otherwise, you have to have a kind of a hub. To create a graph, you have to have a hub of your x and y intercepts. Now, once you get all those things, your x and y intercepts are pretty important. These aren't usually huge. We don't usually ask what is your domain, what is your range, but it's good to know, to kind of get big picture, to think about it so you don't kind of get confused. Vertical asymptotes come with rational functions, rational or fractions. And it produces a non-zero numerator and a denominator of 0. Okay. Basically you set the bottom equal to 0. Whatever you get for that, you plug it back in, and then when you plug it back in, if you get a numerator that's a constant and a denominator of 0, then it was a vertical asymptote. Those are very, very important to clarify, to find. They really help when you sketch. Okay. Slant asymptotes we've never talked about. We'll talk about those more later, but basically slant asymptotes come when you have rational functions. You have no common factors, which we'll talk about, and it has a degree of the numerator exceeding the degree of the denominator by 1. So the numerator has an x cubed, while the denominator has x squared. When there's a change of 1, you can have a slant asymptote, and when nothing factors out, meaning it's non-removable, it's not an asymptote. Okay, it is a non-rational part of the function using long division and rewrite your rational functions. Basically, long division is going to come back into play. You're going to take a fraction, long divide it, and the remainder, actually you'll see, but this is kind of weird. But we're going to deal with asymptotes that are at a slant. Kind of like, woo, woo. Anywho, when you're sketching your curve, these are the major things you want. Your intercepts, just so you find a point somewhere, or points. Your asymptotes, vertical, horizontal. Actually, I didn't mention horizontal asymptotes because that was mentioned in another section. But you want vertical, horizontal, and slant. Extrema, meaning relative maxes and mins. Points of inflections, meaning first derivative, second derivative. Figure all this stuff is going to be kind of crazy. And then sketch it. It's a long, very, very, very long process. But it puts everything together we've learned so far.